What we're going to talk about today are graphing lines using points and slopes. The objectives are as follows. We're going to find and graph an equation of a line given its slope and a point on the line, its slope and the y-intercept, and 2 points on the line. So let's get started. Here we have an application associated with the formula for cholesterol reduction C. And it's given by the following equation where C is equal to minus 3w plus 215. Here we have y equals mx plus b, and we see that this equation for C is also in the y-intercept form. We also note that w is the number of weeks that has elapsed. And we can draw a diagram of this cholesterol reduction as shown, where W1 and C1 are an ordered pair associated with, let's say here, initial point 0 for week 0 and 215 for cholesterol 1. And we want to see how much is reduced to W2 at week 12, where we have a cholesterol at a level of 175. Using the formula for a slope, change in the rise over the change in the run. So in this case we have C2 minus C1 over W2 minus W1. So the change in the y over the change in the x, or in this case the change in the cholesterol over the change in the weeks. So substituting here, we have 215 minus 175 and 0 minus 12. Here I interchange the roles right here in terms of negative sign, but it doesn't change the answer as long as you're consistent with your subscripts. So we have negative 40 divided by 12, or approximately negative 3.3. So let's see what the point slope form looks like. Again, we have a definition, just a little bit of review, of a line going through the points x1 and y1 and x2 and y2, and that's given by the following relationship, where m is the slope and it's equal to the change in y over the change of x, or y2 minus y1 over x2 minus x1, which is really the rise over the run as defined here. The run is really the change in the x coordinates, and the rise is the change in the y coordinates. And what we mean by a point slope form of the line xy and having slope is given by the following relationship. So where y1 and x1 are points on a line, is a point on the line having a slope m. And we can find the equation of a line if you're given the slope and you're given the x and y coordinates of a point, then you can find that equation of the line. Let's derive that equation real quick. The point slope form of the line and having a slope is as follows, which we discussed earlier. But we note that we can multiply this equation by x minus x1 on both sides of this equation, and we see on the right side that the x minus x1 cancels out, and we're left on this relationship where we have y minus y1 equals m times x minus x1. And then solving for y, we have the following relationship, where this is basically, we can find the equation of the line in point slope form. And then when we solve for y1, that yields y equals m minus x1 plus y1. So let's find an equation of a line. Say we're given a point and a slope. Here's the point, 2 and minus 3. That's shown here. Okay, 2 and minus 3. And we have a slope of minus 4. Okay, so one way to think about this, with a slope of minus 4, we go one step to the left right here, and then we go 4 steps up and we can plot a point here and then draw a line. But let's just, for the moment, use the point slope form. All we do is here substitute 2 for x1, shown here, and -3 for y1, shown here. Now the y minus 3 is just a y plus 3 on the left side, and -4 times the quantity x minus 2. To get rid of the parentheses, we use the distributive law. So -4 times x is -4x. -4 times the -2 equals +8. Subtracting 3 from both sides of this equation yields the following, where the 3's cancel out on the left side, leaving y, and then 4x plus 5 on the right. Based on this form, we recognize that this is the slope-intercept form, where m is -4 and b is 5. Okay, so this is the slope-intercept form. So let's just check real quick. When x is equal to 0, y is equal to 5. That's the equation of this line. And if we substitute 2 into this equation, that leaves -4 times 2 is -8 plus 5 is -3, which is true when we substitute y equal -3. Therefore, we have correctly formulated the equation of this line. And here, this is known as the standard form. Let's look at this point 1, 1. Substituting x for 1, we have -4 times 1 is 4. So that's -4 for this product, plus 5 is 1. Therefore, 1, 1 is a point on this line, and we can visually see that this point lies on that line.